Hi viewers, welcome to Smart Academy. Now we discuss Eamcet, Neet, Jee, IIT topics. First I choose the topic of this work power energy. So what is work here? So work means, suppose if you are taking if you are considering a body here. Now we apply some force, that is F force, on this body. Then this body, if it displaces certain distance, that will be S, then that work done can be written as here F dot S. F dot S. F dot S means this can be written as here Fs cos theta. Fs cos theta. What is the theta here? This theta is the angle between this force and displacement vectors. Suppose let it be this displacement value S. Let the force F, this vector F, if this force and displacement theta is angle between this force and displacement is theta here. So this can be written as Fs cos theta. If we draw a vector, the resultant vector from here top to, from force to this displacement, I will draw a normal vector from here like this. So this belongs to F cos theta here. F cos theta. So for this one, this work done, in this case also we take the F cos theta of S. This W can be written as here F cos theta of S. So this is also gives the Fs cos theta. Okay, this vector diagram for this equation. Suppose similarly if we exchange this S and F, then for that one we take a diagram like this. This is the force, this is the displacement, if theta is the angle between them. If we draw a perpendicular vector from S to F, so this can be written as here, this belongs to this vector is equal to S cos theta here. Okay, so the product of this S cos theta and this force vector, this will also gives work done here. That work done equal to F force into this S cos theta. So this is also equal to or similar to this W equal to Fs cos theta. Okay. So these are the diagrams, vector diagrams for the F cos theta into S. This one for the F into S cos theta vector diagram. Okay. Next one, now we go for units for the work done. Okay. So what are the units for the work done? Is work. So that is always measured in the, so we have the MKS and SI, MKS or SI units and CGS units are there. So MKS units are joule. Joule is the unit of the work. So this M is the unit of this work. Okay. So now this joule can be written as here in terms of newtons, that is Newton meter here. So this will be getting like from the equation W equal to Fs here. So this W measured, the work done measured in the joules here, that is 1 joule equal force measured in the MKS units for the force is Newton, and the displacement, this unit is meter. Okay, but here 1 joule equal to Newton meter. Okay. So in case of CGS units, that is work measured in the egg. So nothing but here 1 egg equal here, that will be equal to force. CGS units of force is here dyne. The displacement measured in the CGS is, that is centimeter. So the dyne centimeter equal to here egg. Okay. Next one, take the another relation here. This 1 joule equal. So already we know that 1 Newton equal 10 power of 5 dynes. So we deduce the relation between here this joule and egg. Okay. To find out that, so we apply that Newton value. How many Newton equal to how many dynes here? That 10 to the power of 5 dynes. 10 to the power of 5 dynes. So 1 meter equal here 10 square centimeter or 100 centimeters. Okay. So then this 1 joule equal to 10 power 5 into 10 power 2. Nothing but 10 power of 7 dyne centimeter. Okay. So this dyne centimeter equal to, we can written as the egg. Okay. This 1 joule equal to this 10 power of 7 eggs. So this is the relation between the joule and egg. Okay. So here if we discuss this work done. So the work done value, which is measured in 3 ways here. Okay. With respect to the constant force, with respect to the variable force. Okay. So this work done, which is measured in the application of the constant force, and another one is the multiple forces, and another one is the variable forces. Okay. Multiple forces and variable forces. This constant force nothing but, so this W equal to, due to the application of F force, if displacement is S, then that can be written as W equal to F dot S, like this. So what we have discussed in previous class, that is W equal to Fs cos theta here. So for the multiple forces, if you are applying the multiple forces F1 like this, F1, if you are applying the due to the F1 force, if the body displaces certain distance, and due to the F2 force, again this body displaces to another distance. Okay. So due to these multiple forces acting on the same body, then that can be written as here W equal to integration of F1 ds plus integration of F2 ds plus integration of F3 ds and so on. So these are all simplified like this, integration of F1 plus F2 plus F3 ds. This is also simplified as, this can be written as sigma Fr here, sigma Fr, the resultant force here. Okay, the resultant force dot ds. This is the work done equation for the when we apply the multiple forces. Okay, next one, now we discuss about the variable forces. Okay, so when we take the variable forces, we take that variable which will be taken along maybe x direction, y direction or z direction. Okay, so like this, if we are taking a force vector, so we draw a coordinate system here. This is x-axis, y-axis and the z-axis. This object O. This force vector, if acting the force value along the x direction is, let it be fx. into this I cap is the unit vector along the x direction. Same this force vector, if you are taking along the y direction, is Fy. The unit vector along y direction is, let it be j cap, and the force vector along the j direction is Fz. The unit vector along the j direction is, let it be k cap. Okay. The resultant force for this variable force can be written as here, resultant vector F equal to Fxi plus Fyj plus Fzk. This is the Cartesian form of the force vector. Okay. Suppose if this is body which is in the displaced in the space like this, the displacement of the resultant displacement is, let it be ds. Okay. The small displacement is ds. That value can be written as here dxi plus dyj plus dzk. Okay. So this small work done to displace from origin to here or any direction in the space, that dw equal to here, small work done dw equal to, we can written as dw f into ds. Okay. So this total work done in this space can be written as integration of dw, which gives the integration of dw, which gives the total work done here. Okay. So next one, this work done, we substitute this fds values here, f dot ds here. So 1, 2, let it be 3. Equation 1 and 2 substituted in the equation 3. So then we are getting this w equal integration of fxi plus fyj plus fzk dot, this one is ds value, how much? That is dxi plus dyj plus dzk. Okay. So now we apply the dot product between these two quantities. Then we are getting I dot I value 1. We know that j dot j value also 1 and k dot k also 1. So that's why we are getting the fx dx here for this one plus fy dy plus fz dz. Okay. This is the work done when we apply the variable forces which are along x direction, y direction and z direction. Okay. Next now we discuss the other units for the this work done. Other units for work done. What are the other units here? This one work done also measured in the electron volts. So this one also energy also measured in the electron volts. Nothing but energy and work done both are having the same units. Okay. That electron volt value 1.6 into 10 power of minus 19 joule. Okay. So another unit for this work done is kilowatt hour. Kilowatt hour. So 1 kilowatt hour equal to 3.6 into 10 to the power of 6 joules. Okay. So these are the other unit for the work done. Okay. Now we discuss the nature of the work done. Okay. The nature of work done which will be taken, it may be positive or negative or zero. That is depend on the displacement of the force and displacement, the relation among the force and the displacement. Okay. Okay. Nature of work done. This work done may be classified as 3 types here. That is the positive work, negative work and zero work. Okay, nature of the work done we can classify that here three types: positive work, negative work, and zero work. So what is positive work here? Positive work nothing but this force and displacement on particle. When we apply the force, if the displacement of the particle or body which are in the same direction, that is called positive work. Okay, so in this case, suppose this is a body. If you are applying force like this, F force, so if we observe the displacement of this body, which is also equal to or in the same direction, along the same x-axis direction, then that is the work done can be treated as the positive work. Okay, so in this case, if you are observing the angle between force and displacement, that should be always theta, always less than of 90 degree. Okay, this is the acute angle. So when the angle made by the force and displacement is less than of 90 degree or acute angle, then in that case also the work done is positive. So we treat it as the work done is positive here. Okay. Suppose in this case you can observe easily when we observe the body that is freely movable, freely motion of the body where we are observed, that is that work done is always positive. Okay. So let us see some examples here. Suppose if you are stretched a loaded spring here, when we apply the force in the downward direction, this displacement of the string or body also in the same direction. So then the work done we say as the positive work done. Okay, here when we pull this load to the downward direction, the applied force is also F in the downward direction here. We can say that the displacement of the spring, the extending, when it extending, the displacement of the string also in the same direction. That's why the stretched spring is a good example for the positive work. Okay, and as well as when we drop a stone freely from certain height, so which is also equal to the positive work here. That work done is equal to positive. Why? Because of when it is moving, the displacement of the stone is in the downward direction, as well as the gravitational force also towards the downward direction. Okay, here force and displacement are in the same direction, which are in the same direction. So this one also, this work done also belongs to the positive here. Okay, so for negative work nothing but here we can say that force and displacements are opposite direction. When we apply the force, the displacement in the opposite direction, then we can say that is negative work. Okay, simple that example which are observed in the retardation in the car. Retardation in a car. When car moves like this, when we apply the sudden brake here, the motion of the force in this direction, the frictional force is upward in this direction, but displacement of car in the opposite to the force. So this is the retardation is a good example for the negative work. Okay, suppose if you are projecting a body from floor, then which is also this work done is also negative here. Why? Because of when we apply some force here, this gravitational force, when we projected some body or particles or a body or object, that force is always working in downward direction, but displacement of this object is in the opposite to the gravitational force. That's why this work done is here. We are taking the negative. Okay. Next one, zero work done. Zero work done nothing but if the angle here, what is the angle here? Angle between this theta, angle between the force and displacement, that should be 90 degree here. That should be 90 degree. Okay. This is called acute angle. Acute angle. Next one is the zero work done. Zero work done nothing but this already we know the W code here, Fs cos theta. If theta is 90 degree, if you are putting the 90 degree, then this become work done become 0. Cos 90 value 0. Then that's why this W equal to 0. Okay. So theta 90 degree means, suppose if you are taking a porter kept a suitcase or a luggage on his head. Suppose he moving, let me consider he moving in the forward x-axis direction. Then the displacement of this luggage, which is in the x direction, means that is displacement, that will be s. The force, gravitational force of this luggage, which is acted in the downward direction, normal to the downward direction. So this angle between the force and this displacement, that should be 90 here. That's why this is zero work done here and the zero work done here. Okay. So next, if you are observing the not only this one, if your displacement is 0, suppose if you are applying some force on this board, if this board displacement is 0 here, that's if we are putting s equal 0, in this case also we are getting the same work done. If displacement is 0, then work done also 0. Due to the application of force, the wall does not move. That's why this displacement of wall is, we can say that 0. When displacement is 0, the work done also 0. Okay. Same, if you are observing the revolving of a satellite around a planet, so which is also equal to that work done also equal to the 0. Why? Because of this one has the constant velocity. When velocity is constant, acceleration should be 0. What is the acceleration? A equal to dv by dt, the rate of change of velocity. When velocity is constant, the constant differentiate with some time, then we can get the 0. V is constant, then acceleration become 0 here. When acceleration is 0, then the force value, force equal to here